Hello folks, we are coming to the part 8 video of this exercise 1.1 where we continue with our problem number 9. Now problem number 9 is defined on the set A, which is all the integers which is lying between 0 and 12. So little huge set, 12 elements are already there. So we won't think of listing it. That should not be a good idea, so we leave it. And I think they ask us to show that it's an equivalence relation. Let's check what they say. They tell that they ask us to show that it's an equivalence relation. So let's find out whether it's an equivalence relation, and then whatever little questions that they have asked us, let's answer that, and that's how we are going to proceed. So let's start with reflexivity. See, if you can see the question, it's a little familiar to what we did in the previous one, where modulus of a minus b is even. It was even where, like, it was 2 something, and here it's like going to be 4 something. Very familiar, like with what we did previously. So reflexivity. Whenever we do reflexivity, we will consider AA. And here we have to check. Therefore, modulus of a minus a is 0, which is 4 into 0, that is a multiple of 4, like that. A comma A belongs to R. That's how R is reflexive, and that's equation number 1. Then we go for symmetricness. Right, let A comma B belong to R. So therefore, if A comma B belongs to R, A minus B is equal to some 4m, right? Because they've said like, so that is as good as saying B minus A, as we saw in the earlier case. Yeah, because modulus, it just doesn't affect. Modulus, if you take whatever way around, the modulus will take care of the value. So therefore it is going to be 4m itself, and that will mean that B comma A belongs to R. Because it's a modulus, it is taking care. So starting with AB belonging to R, you've got BA belongs to R. Therefore R is symmetric. And that's how you're getting the equation number 2. Now we will check for transitivity. And for transitivity, let's check. Let A comma B and B comma C belong to R. So that will mean that therefore A minus B is some 4m1 and B minus C is some 4m2, where m1 and m2, they belong to integers. Now see, this is not going to be much helpful to us, so we kind of convert. Therefore A minus B is plus or minus 4m1 and B minus C is plus or minus 4m2. Consider A minus C. We are looking out for transitivity, so that is A minus B plus B minus C. Adding and subtracting B. So this part we know it is plus or minus 4m1 and this is plus or minus 4m2. 4 you can take common, plus or minus m1 plus or minus m2. Since we are interested in the modulus, A minus C is anyhow a multiple of 4. Right, because this will take care of the plus and minus part. So that's how you have A minus C is a multiple of 4. Once that is the case, A minus C can belong to R. Thus, for A comma B and B comma C belonging to R, we have A comma C belonging to R. Therefore R is transitive. Right, equation 3. So what happens from 1, 2 and 3? It becomes an equivalence relation. R is an equivalence relation. Okay, as though this is not enough, there is some other question that they have asked us. Let's see what they ask us. They ask us that find the set of all elements that is related to 1. So we'll find out all the elements that are related to 1. That's easy, like how we had done before. Here, let A be 1. Okay, so we will do the difference, and wherever it is a multiple of 4, we will write that. So first we will start with, see, 0 to 12 we have. 1 minus 0 is 1, will not take. 1 minus 1 is 0, we will take. 1 minus 2 is 1, we will not take. 1 minus 3 is 2, we will not take. 1 minus 4 is 3, we will not take. 1 minus 5 is 4, we will take. 1 minus 6, 1 minus 7, 1 minus 8, 1 minus 9 should be okay because it will come to 8. It's a multiple of 4. Then 1 minus 10, 1 minus 11 and 1 minus 12, all that is not going to work. Therefore our B values here are 1, 5 and 9. So 1 comma 1, 1 comma 5, 1 comma 9 belongs to R. That's what they have asked us. What all elements are related to 1? So elements related to 1 are, we have written B, but again, therefore elements related to 1 are 1, 5 and 9. Okay, that's the scope of that question. Now we go to question number part 2. What is the part 2? Very simple. A equal to B. Relation R is a set of all the elements AP such that A equal to B. We have to check that and we have to find out whether it is an equivalence relation. So let's start right away with the reflexivity. As we did before, consider A. Yeah. What happens? Therefore A equal to A without doubt. So whenever we have both these elements equal, it will belongs to R. So R is reflexive. These are trivial cases, where it is going to be like it's quite natural. Symmetricness. Let A comma B belong to R. Because it is belonging to R, it's clear that A equal to B. If A is equal to B, there is no harm in saying that B equal to A, right? Doesn't matter. So therefore B comma A, these things are very sensitive. B comma A belongs to R. So thus, starting with A comma B belonging to R, we have got B comma A belonging to R. So R is symmetric. That is equation 2. Then we go for transitivity. Let A comma B and B comma C belong to R. What is the meaning? A equal to B and B equal to C. We know it. A equal to B and B equal to C means A equal to C, because equality is a transitive relation. So therefore A equal to C. Therefore A comma C belongs to R. Thus, starting with AB and BC belonging to R, we have got AC belonging to R. Therefore R is transitive. Right. That is our equation number 3. So from 1, 2 and 3 we have it as an equivalence relation. R is an equivalence relation. Now same question is asked, what all elements are related to 1? How, say if you have a set 1, 2, 3, 4, 5, 6, 1 cannot be equal to anything, isn't it? So, see, let A be 1, then B also has to be 1. Otherwise, how, if they have to be equal, as A equal to B. Therefore, 1 comma 1 belongs to R. Therefore, element related to 1 is 1 only. Right. So that is about this. And that's how we are done with this video. With the remaining problems, we'll meet in the fresh video. Thank you.